Hello and welcome back. In this video, we'll be working through an example of sketching the level curves for a function of two variables. In particular, this function, f of xy equals e to the negative x squared minus y squared. Now, this is clearly not a quadric surface, so we can't really compare this to our table of quadric surfaces and be able to reasonably tell what this surface is. So we really, the way to understand the surface is through its level curves. So again, what we'll do is we'll set f of xy, we'll set the height to various constants and see what curves come out. We'll plot them in the xy plane, and then we'll sort of stack them up on top of each other to better understand what the surface looks like. Now, one thing we can do here, so we'll start with z equal e to the minus x squared minus y squared. One thing I can do here is just set z equal to any constant, an arbitrary constant. So I'm going to call that z naught. So I'm going to say up here z naught, an arbitrary constant. And if I just solve this out for z naught, this will tell me what my family of curves looks like based on what z naught is. So that is, I'll set z naught equal to e to the minus x squared minus y squared, and solve this, try and make this look like a curve that I'm familiar with. So I have this e here, so one thing I can do is take natural logs on both sides to get rid of this e, and so this will give me natural log of z naught is equal to minus x squared minus y squared. And then I can, this doesn't quite look right to me. I have minus x squared minus, if these were both positive, this might look like a circle. And so I'm going to solve for, I'm going to multiply both sides by -1 and make these both positive. So that's going to give me, I'll move it over here, x squared plus y squared equal negative natural log of z naught. So this negative natural log of z naught, this is a constant. So I have x squared plus y squared equal to a constant. Well, that's the equation of a circle. Right? This is a circle centered at the origin, with radius, not negative natural log of z naught, but rather square root of negative natural log of z naught. So remember the equation of our circle, this is r squared over here. So our radius is the square root of this. So our family of curves looks like circles centered at the origin of varying radiuses. Now the fact that this is negative natural log of z naught in here, and it's under a square root, means natural log of z naught better be negative, so that negative natural log of z naught is positive, and I can actually take a square root. So let me just make a note of that up here. We need, in order for this to actually have a curve at that height, we need negative natural log of z naught to be greater than or equal to 0. And then remembering how natural log works, how do we get negatives out for natural log? Well, okay, well let me go. So this, if I multiply both sides by -1, this is going to be telling me natural log of z naught needs to be less than or equal to 0. So I need natural log of z naught to be less than or equal to 0. What values of z naught give me something like this? Remember, I need natural log looks like I need the input to be between 0 and 1. Remember, natural log of 1 is 0, and if I'm between 0 and 1, then natural log spits out negative numbers. So this tells me that I need z naught. Z naught should be between 0 and 1. 1 might work out. Let's see what happens when we put 1 in. So let's do z naught equal to 1. So negative natural log of z naught, that'll be 0. So that'll be a circle with radius 0. That's kind of weird. What do I get? I get x squared plus y squared equal to 0. And the only solution to this is a point, right? This isn't even a curve, it's just a point. 0, 0, and then z is equal to 1. So that's what I can start with, is I just have a point on the xy plane at 0, 0, and this corresponds to z equal to 1. So at z equal 1, we just have a point. This either represents the bottom of a bowl shape or the top of a hill type shape, of a bump. It's probably one of those two things. The only way we can rectify whether it's the top or the bottom is to continue to graph level curves. So let's say I pick z equal to 0.9. Let's do that. Let's pick z naught equal to 0.9, say. Remember, we need to be between 0 and 1. I'm going to have to get my calculator out. Then let's see, natural log of 0.9 is like negative 0.105 when I plug that in. If I do negative that, so times negative 1. So now I have negative natural log of z naught, it's about 0.105. Take a square root of that to get my radius. I get a radius of about 0.32. So I'm going to mark here on x and y. Maybe I'll do 1 here and 1 here. Negative 1, negative 1. So at z equal to 0.9, I get a circle, looks something like this, at about 0.32. So I'm just trying my best to estimate where 0.32 is. Again, this doesn't have to be exact because we'll have our labels around with it. So this was 0.32 about. Right, we end up with x squared plus y squared equal to about 0.324 squared. So that gives us that circle. We can do the same thing. So this would be our radius. So radius is 0.324. And I can do this for each of these z naughts. So how about I pick 0.8? So the fact that z naught has to be between 0 and 1 tells me, okay, what kind of heights am I going to sketch? Well, how about I go by 0.1? And I can do the same thing here with 0.8 and figure out what my radius is here. So 0.8, again, I'll do negative natural log of 0.8 and take a square root to get the radius. So this has a radius of about 0.472. And so at z equal to this was 0.32. This was at z equal to 0.9. Remember, label with the heights, not the radiuses. So that was at 0.9. And then here, this is about halfway between 0 and 1. That's 0.8. And let's see if I go to 0.7, I'll get a little bit bigger. So we can do this for a lot of these. I could even make a little table here. How about I make a table over here? So I'll have my z naught value, and then I'll have the radius over here. And we've already did some of these. So when z naught was 1, the radius was 0. When it was 0.9, the radius was 0.32 something. When it was 0.8, we had the 0.47. Maybe I'll just stick to 2 decimal places of rounding. So when I do 0.7, remember this radius is the square root of negative natural log of z naught. That's what I'm graphing here. So let me do that. Negative natural log of 0.7. Take a square root. And I get 0.59. And keep doing this for these. Here I get 0.71. I can do it for 0.5, negative natural log of 0.5. Take a square root. I get 0.83. So notice it's getting closer and closer to a radius of 1. Do we ever get a radius of 1? We can ask ourselves, do we ever get 1 out for a radius? Well, in order for that to happen, I would need 1 to equal square root of negative natural log of z naught. So I get 1 equals negative natural log of z naught. So let's see, I need natural log of z naught to equal negative 1. Take e to both sides. I get z naught equals 1 over e. One over e is about 0.36. So at the height of 0.36, so that'll be down here, right? It should be between these. We should cross over a height or a radius of 1. So let's see. Let me do 0.4, negative natural log of 0.4. Square root of that. Get 0.95, right? I'm really close to 1 here. Let's do negative natural log of 0.3. Should now get something bigger than 1. Yep, I get 1.09. And we're going to go all the way. So what happens is I get close to 0. So let's do like a 0.01, something like that. As I get really close to a height of 0, what comes out? So negative natural log of 0.01. Ooh, that's getting big. Square root of that. Get something like 2.14. So my radiuses are getting really big as I get close to a height of 0. Right? So I can just kind of finish these out. So, right, so where was my radius of 1? So let me maybe do 0.7. Was it 0.59? So there's 0.7. And I do want these heights to increase. If I'm going by 0.1s, I want to keep that going. So that would be 0.7 here, 0.6. And the point is we can just keep making these and then ask ourselves, if we stack these on top of each other now at these different heights, what does my surface look like? So try and imagine the surface now. It looks like this point is the peak of a little hill, right? This is at z equal 1. Everything else, we're decreasing from this. And then as we get close, my radiuses are going to really span out when I get really, really close to 0. I'm going to get really big radiuses. So what does this surface look like? Let's reveal it. There's my surface. So that's the graph of this function. We were able to hopefully get a nice visual for that by just looking at the level curves, by understanding this. If this isn't what you had pictured, again, try and force yourself to think, okay, what was my misunderstanding? Why didn't I see this surface coming out? What was going on there? How can I sort of fix my intuition for next time? How does that change my intuition? That's what you should be working on as you practice these things. All right, that's it for this video. We will, in the next video, look at a different curve. We'll look at this one. Ooh, definitely not a quadratic surface. This one will be interesting. We'll study it in the next video.